Hey, so I think we're all here. Why don't we get started? If anyone's having any troubles opening the notebook, definitely let me know. But otherwise, we'll get going. This is day 4, the 4 of 4, the final day. This is the ride or die crew, the die-hard data science team. So thanks to everyone for attending, and I'm glad that we've got a good group here. So we're going to get started. Open up your notebook. I'm going to go ahead and share my screen. Whoops. There we go. Cool. Let me know if you're not seeing that. But today we're going to continue our conversation about pandas. Again, pandas is basically, a cornerstone of the data science toolkit in Python. And so, like I said last week, it's a huge package. It's a huge library. So it's not something that we're going to memorize, but it is something that we should definitely familiarize ourselves with because it's going to be really important for a lot of the work that we're doing in data science. So we wrapped up last week and we were going to talk about selection. So let's dive into that. First and foremost, we're going to be using a method called loc, or kind of short for location. Let's take a look at the docs. Essentially what it does is it accesses a group of rows and columns by a label or a Boolean array. So we're looking at a few different things. Let's import our packages. Of course, this keeps happening to me. My kernel times out right as I get started. I'm going to refresh here real quick. Hopefully that works for me. Yep. And we're looking at the same data we were looking at last week, which was the European data that is in your data folder. And just so that we're looking at the same thing and we're kind of familiarizing ourselves with this, let's take a look at what we've got. Where is that data? So this is kind of the basic European data that we were looking at. We've got our country, we've got our unemployment rates, our GDP, median income, total population, and it's a very small data set, right? It's only 32 entries, but we're going to be bringing that in. And again, looking at the head of it, we're looking at that here. We're looking at the interactive data frame in our output. And we want to kind of talk about how we're going to be accessing this data using the location method or loc method. And to do that, just to demonstrate that, I've pulled this data, I've just written it by hand and put it into a Python dictionary. And I kind of wanted to just map our understanding of how to access data in a Python dictionary to a Python data frame, or I'm sorry, a pandas data frame. And so what I've done here is I've just taken a standard dictionary and I'm adding a key of 15. And then at key 15, it's going to be the country data, as you can see. So if we look at, if we want to get all of these or many of these, we'll see the data for Italy. And all of this data is just written by hand here. And so we're going to read that in, and we'll say the countries dict, we're accessing it at 15. And then we're going to write in the country key on that, and we're going to get the word Italy, right? Now, of course, this is a little bit awkward because it kind of looks like we're indexing this, but we're not. It's really just whatever key we happen to be using. And oh, sorry. And it's going to be 15. We could also say 15 is great, and it would still work as our key. Keep forgetting to update that. But for now, we're just going to use an actual integer of 15 because we're going to be using that as an index down the road. Right. And so how do we do this with a data frame? That's the question that we're trying to answer. And basically what we're saying is, let me grab this info for you. If we wanted to use something like location, what we would do is take our your data final, and we would actually call that right on the data frame .load. And then we're basically accessing it at key 15. And furthermore, we can then pass in an additional thing that we're indexing by of country. All right, so it's kind of awkward syntax, but it makes sense when you look at it that we're passing in two values here, and we're using the loc method, and we're going to drill down into this dictionary. In this case, it's a data frame, but we're going to drill down into that structure and get the name of Italy, right? This loc method is really dynamic. There's a number of things that you can do with it. We can also get by columns. So if we were to say, get multiple columns, I mean. So if we wanted to get, at this particular index, we could also say something like, we want the country and we want the GDP, and we could get that data there, right? We can do that for, any number of things, right? So if we also wanted median income, we could get those values as well. We can get an entire row or entry. So again, we could say, here at the 10th index is the country of Germany, right? Or, any number of those, Lithuania. But of course, if we ask for something that is outside the range, it's not going to find it because it's not there. And again, when we're talking about the index, we're talking about a very specific thing. We're talking about the index. It's actually an object that's specific to pandas. And that's going to be what the data frame is actually indexed by. So if we take a look again, we're seeing that this is the index here. And so we're just basically grabbing that index and saying, we want this particular country, and we're able to, grab that back. And, if we wanted Denmark, we could get that, or, whatever. We can get multiple rows and columns. So we can do the same things if we said your data final. Then we can also say, I'm going to get, Denmark and whatever the next country is. And we also want, let's see, country and GDP. And this also supports Python kind of slicing syntax. So if we wanted, for example, the countries starting at 6 and ending at 10, we could get, whoops, hold on. There we go. Sorry about that. We could get that, and then we're going to get GDP. All right, so notice here, I made a little mistake there. This isn't a single, we're not passing in an array. We're actually passing in a single argument, and that just tells the location method, the loc method, that we're going to slice in this way. Right. So right now we're indexing, like I said, by integers. But if we wanted to, sometimes I find it's a little bit easier to think about, kind of wrap my head around using the loc method when it's indexed by like a specific name, like a country name. So what I'm going to do here is just write this out for us. Country index. So the your data that is indexed by country, and we're going to take your data final. We're going to sort the values by country, right? So again, let's just take a look at what that does. Oops. Your data final, that's sort. Oh, sorry about that. Sort values. Right. And it was already sorted like that, but we want to just make sure that we're going alphabetically. And then we're also going to be setting the index. Right, so we're telling our data frame, remember, that we want to set our index to the country column. And we could also set it to the GDP column or the total population column, but it's just that isn't data that is kind of front of brain for us. So I find this is just going to be easier for us to work with. So notice how the format of our outputted data has changed. So now this particular row is accessible by the term or the country name Austria. And we can look at that here where we say .loc, and if we want Denmark, we're going to get it. Right? Whereas if we tried this, that would not work because what this is saying is give me the index of Denmark, and it doesn't exist. We have to create that with the country index. And then we can, of course, if we spell it right, and then we can go from there. So we're going to do a quick exercise at that. What I'm hoping you can do is use the loc method to create a new data frame. And that should have all the countries from Cyprus to France alphabetically. And we're looking at getting the GDP and total population columns. So we should be able to do that in a single row, and all the information is up there. We'll just take 1 or 2 minutes right now. Go ahead and try that. All right. Did anyone get it? Did anyone want to share theirs? Yeah, this one's not too bad. So we're going to be starting with the country index. And again, we're going to use the loc method. And we want to basically start with Cyprus, and we want to end with France. And then we want to pass in the column names that we want, and that's total population and GDP. And then we will, of course, have to spell it right, and we'll get the data frame that we want. Notice here that I mentioned that it was kind of standard Python slicing in notation or syntax, but there's a slight deviation in that it is inclusive of the final value. Normally with standard slicing, it's not, but in this particular case, it will be inclusive of that value. Cool, so we're gonna do a longer exercise, and we're gonna pull on some of the stuff that we talked about last week. And so the question is, what countries have a higher unemployment rate than Slovenia and have a lowercase t in their name? Right, so some of the steps we want to go through are selecting Slovenia and selecting Slovenia's unemployment values. We want to generate a comparison query, which is what we were doing last week with that Boolean indexing, creating basically a Boolean array. We also want to check if that will actually contain the letter T. And then we're going to actually do that selection using the ampersand as an operator. So take just a minute. If there are any questions in advance, I know that that's sort of a lot of stuff, but we're pulling on some of the material from last week, and then we'll jump in and do it together.
I have a question.
Sure.
Before, is it necessary to do the sort value before set index, or is it just independent?
That's a good question. It is not necessary. One particular reason that you might do that is just so that you know the index that you set is going to be sorted. But the setting of the index is not dependent on how the values appear. That's just a way for us to know that it's going to be ordered when it's actually done.
Okay, thank you.
Yep. And I'm just going to add our comparison query just as a hint. This is what we're looking at. All right, so this was the query that we generated last week. We're looking at a comparison between a particular column, and I'll use bracket notation. And this value that we're hoping to select above it. Cool, so why don't we wrap up? And we'll walk through it together. So again, we're getting a data frame at the end. So we want the data frame that has all the countries that have a higher unemployment than Slovenia and have a lowercase t in their name. So what I suggest we do is kind of, we're gonna grab Slovenia unemployment, and we're gonna do that by saying your data, and this is gonna be the data frame that's indexed by country. And we're gonna select it on Slovenia, and we're gonna select unemp rate. All right, so let's just take a look at what that returns. Slovenia unemployment. All right, and that's just going to give us a value. All right, just like we were looking at up here when we were accessing it, we're just able to actually get that particular value at that particular place in the data frame. Okay, and then we're going to use this comparison operator. And again, let's just take a look at what that actually is going to return. Oops. And this is going to be our Boolean array. All right, so we can use this as essentially a mask on the data frame that says which rows should be returned, right? So the 0th row should not be returned, the 1st row, the 2nd row should not be returned, the 3rd row, etc. So that's our first query. And we want to combine it with a second query, which is all of the T names in the particular data frame. All right, so the your data final, and we're going to get each of them at the country, right? So we're getting all of the country names. And so if we're getting all of the country names, how are we actually checking if they have a T in there? Remember, we had this really nifty attribute, the str string attribute that we're able to access and say contains T. All right, so now our T names, again, is going to be a Boolean array, but it's going to have all of the rows that actually have a T in the name of the country as true. So then how do we combine this? We're going to say your data final. That's going to be our data frame. And then we're going to access it using GT, so greater than Slovenia, unemployment. And again, the ampersand for T names. All right, remember we saw that the ampersand was an intersection in set theory. And then the pipe was the basically or, right? So we're going to use the ampersand there for intersection rather than union. And we're going to get that value. Cool. Any questions about that? Yeah, so that's basically an example of how we might use loc. And you're going to use it a bunch and in a lot of different ways, but that's a good introduction to it. In addition, we have iloc. This is something that the main difference here, I put a little Stack Overflow link in there, but the main difference here is that loc refers to like the labels of the particular rows, whereas iloc will actually access by the particular index. And location, loc you can also do index, but iloc you are exclusively looking at the index. So if we were to essentially say your data final, we see the index values here, and we could say iloc at 5. Oops, sorry. We're going to get that value. Again, we can also do this with loc, and it basically gives us the same thing, but we can't do country index with like Denmark, right? So generally speaking, use loc. Sometimes it's a little bit more explicit to use iloc, but it's up to you how you'd like to handle that in your pipeline. Cool. So next up, we're going to be talking about multi-indexes. I know we spoke briefly about that last week, and there was a question that came up. This, I think, is a really powerful feature in pandas. It's something that for me is really an indication of how it can exceed what you can do with an Excel spreadsheet, or at least to do an Excel spreadsheet easily. It just kind of makes the data processing part, I think, a lot more streamlined and frankly visually appealing as well. So we're going to look at that now. The idea is that we're sort of looking at a hierarchical nature of our indexing, and we're going to take a look at how that works exactly. So basically what we're going to do is we're just going to set up kind of dummy data to kind of demonstrate this fact, and then drill into it a little bit more with actual data. But the idea is that we're just going to make a parent array here, whoops, and then a child array, and we're going to combine them. So of course, if we look at what's in the arrays, we're looking at an array of arrays, right? So we have the first array up here and the second array up here, or second array down here. So we're going to combine that, and that'll become useful in a second. And then we're going to, so those will essentially become our indexes. And then we're going to look at generating data for it. If you haven't seen this before, with NumPy, we're setting the random seed value. Of course, our computers can't generate random numbers. There has to be some number that goes into the function to initiate the random number generation. And this is a way for you to just set it. So that when you do pass in a number here, it just tells your global environment, this is the number that I want you to start my random number generation with. And that will basically say that every random number that I generate from here on out will be the same. And that just makes things more repeatable, especially in a notebook environment. If you were to be, working in a pipeline environment that actually valued random numbers, you wouldn't want this seed to be set. But in any case, this just helps us kind of have the same numbers to look at. So what we're going to do is we're going to create a multi-dimensional array of random, quote unquote, random, pseudo-random values. And we're going to use our rand int method. We're going to get 10 values, sorry, up to 10, and we want our size to be 8 and 4. And we're passing those values in, right? So that's going to be the shape of our MD array. I'm having a hard time typing today. So if we wanted it to be 4 by 4, we could do that. If we wanted to do 12 by 4. All right, so we've got our random values and we've got our indexes up here, or at least what will become our indexes up here. What we're going to do is we're actually going to create these values and we're going to create a data frame with them. And then we're going to check what the actual index looks like. Right, so it says it's a range index. What does that mean? Let's just take a look at what is returned here. Notice that this data frame, it has our values, but Pandas kind of had to figure out how we wanted, 1, our rows indexed, and 2, our columns handled, right? And it just says, hey, you didn't tell me what you wanted, so I kind of picked some values. Hopefully that works for you, right? And that it is essentially saying, because you didn't say anything, I'm just choosing to count them up, incrementing them. And so we actually have this index value, right? But we don't want that. That's not super helpful to us. So instead, what we're going to do, so we did this step here, and we're going to copy it down here. But instead, we're going to say, this is specifically what I want our indexes to be. All right, so if we run that, we're going to see what do our data frame become. It actually says this is going to be our first index, and then it also says this is going to be our second index. All right, so this is what you would call a hierarchical index. All right, so notice, for example, that all of these, so 1, 2, 1, 2, and we have bar, bar, baz, baz, foo, foo. And so what it's saying is that each of these individual unique values of bar, of baz, of foo, all of them have a 1 and a 2 corresponding indices, right? And so as a result, the Pandas data frame can actually collapse that and say, thank you for organizing the data for me. This is how it should be presented. So we can go through and then say, in addition to that, we want to set our column names. So again, we're making up data here. So what I've essentially done is said our var1, our var2, our var3, and our var4. And we're actually going to set our columns to be those names. All right, so again, let's just take a look at what our multi-df looks like. And we've now dictated how we want this data organized and how we want it to be displayed. So let's go ahead and start selecting some of these. So if we said multi-df.loc, we can select all of the columns and rows for bar. Right, so again, we're using loc to select here, but we're selecting everything that is underneath this hierarchical index, which is 1 and 2, and we're seeing those values returned here. So it's really great because it's a grouping, right? So let's look at some different ways that we can actually access this using loc. For example, we could say multi-df.loc, and again, we're going to use the same indexing that we were using before, and we can say we want our values at foo and at v1, and we're going to get 1 and 4. All right, so we can also do bracket notation. So if we wanted to say foo and var1, you see the difference there? it's the same thing. And if we wanted to use dot notation, we can do that as well. We could say foo dot var1. Whoops, what did I do wrong? Keep spelling wrong today. Right. And without loc, of course, we can do that as well, where we would just do, select the column itself. And we can get it that way. We talked a little bit about last week about the differences between, doing bracket notation or dot notation. Again, this is up to you. I prefer bracket notation, generally speaking, but that's going to be a personal preference in a lot of ways. The reason I'm showing all of this is basically to say you're going to see a lot of different ways that data is accessed in pandas. And so it's good to just be familiar with the sort of flexibility of the syntax. Any questions about that? Cool. So let's move on to group by. Again, this is really exciting for me. I really don't enjoy working with Excel, and so when we get to group information like this, it really just makes things a lot more powerful, a lot more beautiful in my mind. It is a part of a paradigm, an approach in data science in general, and it's basically, from the documentation, it says a group by operation involves some combination of splitting the object, applying a function, and combining the results. And this is the split, apply, combine strategy in data science and statistics in general. And so there's a great paper, kind of famous paper about this by Hadley Wickham that you can read. And there's a bunch of information online about what split, apply, combine is as an approach and how it can be helpful to you. But this is, the group by and a number of other methods are a way for us to kind of apply that strategy in our data science and be more powerful in our work as a result. So let's walk through a couple examples of that. We just finished up with some dummy data, and so let's now kind of move on into some more real world data. I'm just going to open that up for us so we can see what we're looking at. This is UN data that I grabbed. This is for the world. And if I can select this properly. What we're looking at is every country, and we're looking at surface area, population in thousands, population density, sex ratio, GDP, a number of sort of just variables that might affect any one country at any one time. And it's a huge amount of data, right? So this is what we would call a very wide data set. There are a number of columns that is really too much for us to really consider right now. So we're just going to read that data in. Again, we have that data frame and we can inspect it, if we wanted to, take a look at it, right? And we get the values, we get the averages, we get the standard deviation, et cetera. And we just can take a look at the head and kind of get a sense of what we're looking at. But again, this data is really wide. So what we want to do is we actually want to drop some of these columns, right? And we're just going to focus on these for now. Country, region, surface area, the GDP, the population in thousands, and then the population density. And so we're gonna drop those other columns, and basically what we're gonna do is we're gonna say our UN data is equal to our UN data, and we're just gonna access it by these particular values. So now it's just a little bit more manageable for us, right? We can see it in a single frame of our screen. But another thing here you'll notice is that we're working with column names that have spaces in them, which can get just a little bit strange. So like if I wanted a particular column, I would have to say something like, UN data at this value. And it's like, all right, this is going to get unmanageable. So what I like to do is just rename those. Of course, in the event that I would end up publishing this data or sharing this data, I would want to have it be very explicit what my abbreviations refer to. So I would have a map of original columns to my renamed columns and make sure that that's clear. But again, it's not something that we really want to have to work with. So let's rename them ourselves. And how we're going to do that is essentially create a columns mapping object where it says, what's the original column name and what do we want that column name to become? So we're going to write those in now. I haven't included those, so you can follow along with me. We're going to call this one surface area. We're going to call this GDP. We're going to call this one population. And we're going to call this one population density. All right, so we're mapping what the columns used to be named and what we want them to be named. So again, we're saying our UN data is going to be equal to UN data. And sorry about that, is going to be equal to the rename method applied to our data frame. And we're going to say, what are our columns? Our columns are going to be equal to our columns object. You know, maybe we change it to columns map. Right. So now if we inspect our UN data, all of a sudden it's just a lot easier to work with. Right, so we started with this, which was pretty unmanageable. And we're here now. Any questions about that? Cool. So that was kind of the pre-work for the group by stuff that we're going to be doing. So thanks for your patience as we work through that. Basically, what we're going to be doing here, you'll notice. Let's take a look actually at our data a little bit more closely. You'll notice that we have all the countries of the world, and each of those countries is applied a region. But a lot of these are going to be copied, right? A lot of these are going to be duplicates. So there are multiple countries in Central America and there are multiple countries in South America, right? And so what we're trying to do here is we're trying to say, I want to think about this data not as individual rows per se, but as collections of rows grouped by a particular column value, right? And this is going to be very valuable if you're ever working with species data where you have, you know, a particular set of animals or a particular set of bacteria that might sort of be a part of a single category. If you can group by that category, you can then work with all of those rows within that category in a really manageable way. Right. And so in this particular case, we're going to say we want our data organized by region. And so we're going to take our UN data and we're going to group by what column are we grouping by. And then we're going to say we don't want it to be our index. So if we just look at what that means, we're going to get something here. And the output is going to be a group by generic data frame. Right. So it's not a data frame. And it's not a series. It is its own type called a group by object, right? Which is a little bit strange because it's almost like it's not a fixed entity. It's more of a way of viewing the data frame. It's like a lens into the data frame, and that lens is called a group by, right? So just to give you a sense of what I'm talking about here, we're just going to iterate over this. So what I'm going to do is I'm going to say for region, and then also region DF in UN region. And of course, what we're doing here is we're saying UN region is a group by object, and we're going to iterate over it. And because this object, when you iterate over it, returns both a region and a data frame of that region as a tuple, we can separate that out. We can unpack that tuple into two values, which is going to be the string name and the region data frame itself. So let's just take a look at what that returns, right? So we start out with the string name. That's Caribbean, that's Central America, that's Central Asia. And then we have the data frame. And that's actually going to be the data frame that includes all of the data that's associated with those rows in that region, right? So you would say that a group by object is iterable. You can iterate over it, right? I'm doing this for demonstration purposes, just to show you kind of what we're working with. But and our output, of course, is wildly long. But generally speaking, this is kind of a good rule and a good sort of note to make. You want to avoid iteration in pandas. If you ever find yourself in a situation where you're looping over a pandas data frame or a series, you probably can find a more efficient way to do it. It's just a good kind of indicator. And there's an article here that kind of walks through that. But if your workflow includes a specific Pythonic iteration, you can probably think through it differently and instead use a vectorized operation, which is kind of what we talked about on the first day. Pythonic iteration, kind of vanilla iteration, is really expensive, whereas when you do a vectorized operation, it's going to be a lot more efficient. All right, so anyway, that's our group by object. So let's start working with our group by objects a little bit. What we want to do is we've got our UN region, and we're just gonna take a look at that one more time. Again, that's going to be our group by object. But we want to actually use that, and so we're going to use the get group method. Right, so we're reaching into the group by object, which is a way of organizing our data frame, and we're grabbing out the Caribbean group. Right, and so we're going to then say our Caribbean group is all the countries that fall in the Caribbean. Right, and notice that this is a data frame. Right, so it's just returning a data frame for us to work with. But this is a really just great way to select things, right, by the group. And so again, we can use all the data frame methods, right? We can see the head of it, we can see the tail of it, we can get a description of it. You know, we're very familiar with this at this point. And so if that's the case, if we can do just about anything that we want to this because it is a data frame, I want to do a quick exercise where we get the average surface area of all the countries in Central America. All right, so we want to select this Central America, and we want to get the average of all of the surface area of the countries in it. So take just a minute and take a look at that now. All right, let's walk through that. There's a lot of ways to do this, but how I handled it was getting our values in a Central America data frame. So we're going to take our UN region data, and we're going to get our group, and we're going to select that on Central America. Right, and so from there, so let's just take a look at what that actually puts out. That'll give us a data frame that we can work with. And then of course, we're going to access our surface area column on that data frame, and we're going to get the average and the mean. All right, does that make sense? Any questions on that? right? So again, this is what we're talking about when we talk about vectorized operations, right? This does not loop over every piece of data in a sort of Python way, average them all together, or add them up and then average them all together, right? It uses the power of the data frame and the power of vectorized data to actually do a universal operation on all of the data, right? And so we can do this again. We can do this. So we'll say surface area. We're just going to do this quick. If we wanted to, we could say surf dot min, right? We could say surf dot max, the mean. We could get a count. All that sort of stuff, right? And what's cool is that we can also do this with our regions, right? So we could also get the minimum values of each column on each region, right? So all the regions of the world. So surface area, this is the minimum value of all of the countries that belong to Eastern Africa, right? This is the minimum GDP of all of the countries that belong to Eastern Africa, right? A country is nonsensical, right? I mean, this shows us what that country name is, but it doesn't correspond necessarily to the same row, right? So Burundi is not necessarily the country with the lowest GDP. Cambodia is not the country that necessarily has the lowest population. This is a sort of, again, a lens into the data frame that presents different values for each of those columns, right? Cool. So we're going to move on to aggregating our data. So we're kind of sort of looked at, splitting our data, doing work on that data and then recombining it. We're going to take a look at another way of doing that here. So what we're going to do is we're going to get the mean of each column in the particular region that we're looking at. So we're going to use the .ag method or .aggregate. And essentially what you can think of, the plain English version of this is on your group by object, how do you want it aggregated? And we can say, we want it aggregated on the mean, right? And so we're passing in this mean, which is just a string at this point, but it's kind of a shorthand that Pandas understands. And it says the surface area, the mean for the Caribbean is this value. The GDP, the mean for the Central America is this value, right? And what's really cool is that we can actually then start to add add more. So if we also wanted the median or the sum, we can do that as well. Right, so we're splitting our data, we're applying some function to it, and then we're combining it back together so that we can take a view into it. So I kind of want to just take a quick second, and I know we're running a little short on time, but this is really, really important as you continue working on stuff like this, is the idea of a higher order function in Python. Some of you might be very familiar with this, but the idea is that this is something that you can actually do where you're passing in a function to another function as an argument. Right, so if we said something like add 9, return val plus 9, we could actually do calculation, add in, let's say, the number 11, and then an actual function, which is add 9, and we're adding the add 9 as an argument, and we're doing that calculation to get 20. All right, so it can be a confusing concept sometimes, but the idea is that we're not passing in a value of any kind, we're actually passing in a function itself. And that's what's happening here. What we're looking at is we're going to skip the filtering section for right now, but what we're basically saying is that when we do want to do an aggregation, we're passing in a string here, which makes it easy, and that's just kind of shorthand. But what we can also do is we can also say this, which is a NumPy method for mean, right? Getting the average or sum or whatever. But notice here how we're not actually invoking the function, we're actually just passing in the function itself. And we're allowing this aggregation function to call that function on all of its data. So, right, so when we pass in the mean, we're getting these values. And this is equivalent here. But of course, this is just shorthand. So if we did want to have a custom function that we wrote ourselves, we could do that. And so this is really valued. This concept of using a function as an argument into another function becomes really important. And so, let's say that we wanted to like get max, we're going to write our own function here. We could say val dot max. And this is a silly example because we really could just call max, but it's helpful because then we can say in our own way that we want to get max. And we see that it actually uses the name that we defined to aggregate this data. Is that making sense? Are there any questions about that? And so a couple additional things that we can do. I added this just as a bit of an aside, but you can use the sci-pi statistics module, which is really helpful to add in any number of statistical operations that you wanted to do. So if we wanted to get the skew or the standard deviation or anything else from that sci-pi module, we could get that added in there. In addition, we can do this on a single column, right? So if we said UN region and we just wanted to access the surface area and we wanted to aggregate on, let's say some, we could do that. But notice here, again, this isn't a data frame, right? This is a group by object. And so the idea of accessing the surface area is a little bit awkward because we're not accessing the surface area of the group by object itself. We're accessing the surface area column on each of the children or related data structures of this group by object. Taking all of those, we're aggregating them using the sum method. So the sum of all of the surface area in the Caribbean is this value. So here we are with this particular value, but it's not very explicit, right? So we have all the different regions that we're working with, and the sum column is just a little bit awkward. So what I like to do is when I'm kind of format it. And so what I'll do is call our aggregation function, and then instead of passing in a particular array of operations that I want to have executed, I'm actually going to pass in some keys that I want. And then I'm also going to pass in the operations that I want to have happen. And so let's break this down a little bit. I'm saying of the UN object, the UN region object, the group by object, I want to aggregate for all of the surface area column data. I want to execute these operations. And then I only care about that for surface area, but for population, I actually want the standard deviation. Right? And so we see that here, and we see this is the region value. And for surface area, we're getting the sum and the mean. But for population, we're getting the standard deviation. Let me know if you have any questions about that. So yeah, this is just a way of kind of making it a little bit cleaner. one thing that you'll notice is that, again, these are names that they've chosen. You might have a custom way that you want to display things. So you might say something like aggregate, and I want the sum of the surface area, which is the name that I want to use. And what data is related to that? Well, the column name of surface area and the action that I want to take, which is, NP sum, or, it's smart enough to know that that's what I want. And we can, what did I do wrong? Whoops. And it's defined there. Right. Cool. So we'll take just a few more minutes. We're going to continue talking about this. One thing I want to show you is the idea of filtering these data frame objects. This is really powerful. Again, so we're working with a data frame group by object, and we're going to use the filter method. And so what we want to do is we want to think about this region data as being filtered. Let's start with the concept of population density being greater than 100. Right, so we want a data frame that looks at all the region data, and it only gives us back those countries that have a population density greater than 100. All right, so you could loop through this and again iterate over it and just pick all of the stuff that is over 100. But again, it's going to be really inefficient. So we're going to use a vectorized operation here. And so what we're going to do is we're going to define a function, and we're going to say large pop density, and we're going to pass in our value, and we're going to return our population density is greater than 100. And so this is just a predefined function, a custom function that we want to define. We're going to get a data frame, and we are going to access the population density column. And we want all of the values that are greater than 100. We want to return a data frame with those rows. Right. And so we can actually then say LG pop density as our function. And then we're going to be able to say dot all. Oops, sorry about that. And actually how I want to do this is I want to make this into a lambda function. We're running kind of short on time, so I don't want to go too deep into this, but the idea here is that we're going to pass this lambda function into our filter. And then what we want to do is we want to say, of all of those values that are returned, we only want the ones that are that adhere to this particular query, right? And so we're going to say, these are the values that have a population density greater than 100, right? And so it might look a little bit strange that we would have to add a method like this at the end of it to get all of the values that actually return that query. But if we break this down, it kind of makes sense. So we're looking at a lambda function which passes in each particular data frame that we're looking at. We're accessing the population density on that data frame, and we're going to check for the values that are over 100. But remember, we're not actually looking at each particular region. We're looking at the data frames within the region, right? So what we're getting back is we're getting back a collection of these data frames, and we want to make sure that of all of the ones that are returned, each of them adhere to this particular filter function. So we could also say any, and it says, any of the values that might be returned here do actually pass this test, but we don't want that. We want all of the values that pass that particular test. Right? So we'll do another example here. If we wanted to also look at population, we could say our population is greater than 10,000. And again, we want all of those values, and we're going to get that back. Any questions about that?
Can you elaborate about the lambda function?
Yeah, for sure. So a lambda function, I kind of glossed over this just for the sake of getting through it. But I'm realizing I should go back here and take a look at it. I want to make sure I'm following through on this. Let me pull up my data that I've got. So let's say we did something like this. Our get max value, right? So we define this get max value, or rather, let's just, yeah, our get max value is going to be, I'm sorry, our get max function is going to be defined like this. And this is standard definition for a Python function. We're going to take in an argument and we're going to do some operation on that argument and we're going to return it. But there's a really cool shorthand for functions in Python and a number of other languages. And you can call them anonymous functions. Whereas here we're actually defining the name and it's get max alt. A lambda function allows you to define this without naming it. And you just say, use the keyword lambda. This is your argument, or sorry, this is the parameter that you define. And then this is what happens in the function and it's returned. Right, so it's a strange syntax, but you're basically saying that this is the sort of the method signature that I want to define. It takes in a single argument of x. And then this is after the colon. This is what happens in the function. And then we're actually taking this particular function and we're defining it anonymously and we're storing it in the variable get max. Right? And so if we just wanted to look at sort of a basic example of this, we could define this as right. So we're just going to do a basic kind of function that says is a variable equal to 9, is a value equal to the number 9. We can say that. Or we could say is 9 is equal to lambda val, and that's going to be our argument. And then how do we check that? It's equal to 9. So these are equivalent. Why would we use this? The question is a good one, and it comes up because in a lot of ways, it just makes some of your code a little bit cleaner. So in this particular case, we're looking at a filter method, and we're saying rather than having to define another function elsewhere, we're just going to write in the query that we want using a lambda function, and then use the resulting data and manipulate it. So the short answer is that it's just a different way of writing kind of the same thing, but sometimes you'll see people use for the sake of efficiency, you know, in just writing the code. Does that help at all?
Yeah, thank you.
Yeah, great. Cool. So in the last few minutes here, we're just going to do a quick exercise. There's a lot going on here. We just covered a lot of stuff with the group by, but take a crack at this one. See if you can do this in the next 1 or 2 minutes, and then we'll walk through it together. So we're trying to get the standard deviation for the GDP of each region. and I want you to use the np.standard std, the standard deviation function. And I also want you to query all the regions with a population density over 100. So give that a shot. Cool. So yeah, why don't we dive in and work on this one together. So this is how I did it. Of course, there's a number of different ways to do this, but I selected our UN region data, and I'm using the filter method. And I'm using a lambda function again here. You can do this a number of different ways, but basically I'm taking the population density of the returned data frame, and I'm getting all the values over 100, right? And I want to make sure that I'm selecting all of the data frames that adhere to that particular query. And so I've got that value, right? And so we can see what that is, right? And so, you know, for the sake of clarity, I'll store this. We'll call this high pop dense. And then high pop density, we are going to aggregate. How are we going to aggregate? We want to aggregate on the GDP column, and we want to use the standard deviation, and that's the value that's returned. All right, and we could do a number of things here. We could add them all up. We could, you know, get the mean, anything that we want there. Cool. So we're a little short on time, so I'll leave this section if you want to go through it. Of course, we have the complete notebook here in part 4. But this is just going to, you know, basically walk you through building a correlation matrix with some of this data, which is another really helpful analysis tool when you're doing a preliminary data analysis, exploratory data analysis, or, you know, any number of other activities that you might go through to start off with your data. Cool. So that's the end of the content here. Again, thank you everyone for coming to 4 weeks of this. It's been a really fun ride. We looked at how data is organized in NumPy and, you know, all the packages that are based on it. Again, we're talking about vectorized data, which gives us, you know, allows us to leverage the power of vectorized operations. That's in Matplotlib, that's in Pandas, that's going to be in scikit-learn if you want to take a look at that. We worked, yeah, with sci-pi as well. So Matplotlib, NumPy, Pandas, sci-pi. We did exploratory data analysis, cleanup, formatting, visualization. You know, we looked at the split, apply, combine approach, and hopefully covered a good amount of the activities that you wanted to in this particular course. So thank you again for coming. Before we sign off, are there any questions or comments or thoughts moving forward? Cool. Well, I'm going to stick around for a few more minutes if anyone has anything else. But again, thank you all for coming. And I hope that you can enjoy some coffee hours through FAS Informatics in the future.
Cool, Andy. Thanks again.
Yeah, absolutely. Looking forward to the next one.
Cool. Bye.
All right. Bye.
Thanks much. Bye.